Hello everyone, how are we doing? It's good to be here, it's great to be here in person. So yes, I'm going to talk a little bit about the research we're doing. So it's not quite the same as the social science research, but it's exciting nonetheless. So for those that I guess most people probably do know, but just in case you didn't, the Mining Remediation Authority is a non-departmental public body. So we own the majority of the abandoned coal mines across Great Britain, and we do a lot of management around this. But really, enabling mine water heat schemes is a key part of our business plan, and it's the thing I'm going to talk about today. I'm going to talk today about kind of internal research we're doing, and then some other external research that we're supporting as well. So how do we enable mine water heat? Well, we do a number of things. We provide some advisory services, and part of that is some of these opportunity mapping that we've done, some waste heat source prioritisation, which Stuart will talk about probably a little bit around that later. Mine heat licensing and permitting, which again there's some posters, and Joanne thinks on tomorrow to talk about. But really the research and development is the bit we're going to talk about today. Well, I'm going to talk about. I thought this slide was quite useful. Sarah mentioned it in her keynote, but I thought this slide was quite useful to have up there. So what we've got is in the UK, we've got about 10 megawatts of installed capacity so far. And so really there's some that are potentially coming on in the future, but I think this really sets the scene for what we've got. So, and just on the bottom there, I put the closed loop systems that are in mine water regions, just for a little bit of interest there. So yeah. But what we're doing, so our business plan, really, we've got several key priorities, and this is to contribute to net zero and energy security. We want to work with partners and support R&D. And really, to do this, what we want to do is to understand interactions between mine water heat schemes, to support evidence-based decision-making, and to drive the wider uptake of mine water heat schemes. It's obviously a proven technology, but there's more we can do to try to develop it further. So we've had a little bit of chat about the Mine Water Heat Living Lab, the Gateshead Mine Water Heat Living Lab. So this is a flagship part of our research that we're doing. As Belinda mentioned, can you see my pointer? Hang on. Is that better? Great. As Belinda mentioned, there's the Gateshead Energy Company operational mine water heat scheme here, and there's two other ones in Gateshead. And what we've developed is this monitoring network in between these operational schemes. And really this is to try to understand the interactions underground to see what's happening there. And I think that was the street there that Belinda was talking about, which is turned into social housing that's now on the heat network. This is the picture you see, and as Belinda said, it's not very exciting, they're just boreholes in the ground, but they're exciting to us because we're getting the information and the data from under the ground. So this is a kind of cutaway to show what we've done. We've got at each site we've got two boreholes, because in this situation there's kind of shallower workings and deeper workings. So we're monitoring both of them to see what's happening in between these schemes. And then I just did a little cutaway here to show you what we've got is we've basically got the borehole down into the workings, and we've got this open section of workings at the bottom, which we've got loggers in and data collection devices in to monitor. So what outputs have we got from the Living Lab? Well, one of the key things about it is that we're keen to make all our data open access. We want to make this available to anybody to use to help drive forward research and development in mine water heat. So we've got a data platform on data.gov.uk, so just search for Gateshead Mine Water Heat Living Lab and you'll get the data. And that provides the temperature, conductivity and water level data that we've been collecting. We also did some geophysical profiling, and that a little report's been on there as well, so that's on there. And recently, we've just had an open access paper which has been accepted peer review, so you can have a look at that. It's down the bottom there, and that really goes through the construction of the Mine Heat Living Lab and kind of lessons learned, because we thought that was important. And we're also, our comms team are here, and they are always very good at getting us to do some videos and things. So we've got a nice little list of videos, and we've got a YouTube channel with our mine water heat videos on it. So if you want to go and see some pictures of me taking samples or doing something else, have a look on them. Now, I don't want to talk too much about the data that's in the paper, because I think I've talked about that before, and you can read the paper. But this really shows, what this shows, there's quite a lot going on, and I'm sorry for this, but the blue lines are the deeper system, so the deeper mine water system, and the orange lines are the shallower system. And what we can see here, we see big changes here when the operational schemes switch on. So that shows that we are seeing the interactions here. We're seeing what's happening underground. And as Belinda says, these smaller changes are when Gateshead turns on, and they're turned on and off at shorter durations. So what I wanted to show with this slide is that we are monitoring the system and we're seeing this. And there's lots of data available you can look at your own time. But what I wanted to talk about was some new and novel, exciting things that we've been doing there. So as part of our geophysical survey, we undertook some borehole magnetic resonance. Now, I think this is the first time this has happened in a coal mine workings. Someone may disprove me, but I think it's the first time we've done this tool in the workings. And someone described the tool to me as basically an MRI scan. So instead of looking at your bones, it's looking at the rocks. So it's looking inside the rocks and understanding the storage properties, like the porosity and the water content, but also the flow properties. I think this is the first time we've got that in the workings. So on the graph here, this dark blue line is the caliper. So that's how wide the borehole is. So what you can see is at the top here, this is where the casing is. And then it gets wider, which is when it gets into the mine workings. And actually there's a bit above the mine workings which are fairly solid. And then you get into this open bit here, which is the actual workings, the actual fractured bit. So that's the casing there. That's kind of above that's all within the borehole. And what you can see is you can really see a difference. So the lighter blue line is the porosity. And as you would imagine, as you're getting into this work seam, you're getting a higher porosity as the water can flow through in this system. So this is one of the first times we've been getting this data directly from the coal mine workings, which is quite exciting. We can also see similar things. So this is hydraulic conductivity. So again, this is the same caliper thing to show you where the borehole is. And you can see that the hydraulic conductivity really increases there. Oh, sorry, wrong way. And this is what I want to show you. So this is it doesn't look as good. I wanted to put a video in, but they never really work on PowerPoint, so I didn't put it in. But you can watch our videos. They're available if you want to watch them and sit through hours of footage. But you can see the kind of flat walls here, which is this bit where you're kind of in the sandstones above. And then you can really see opening out into the mine workings further down. So that's this bit here, which is there. And we've also got things for, this for density, pore size, and all the other information that you'd like. So please have a look at the data we've collected. We also went on a little side quest. So we found that when we were doing regional profiling of the living lab, we found that we had a higher gradient than we were expecting. So the estimates of the geothermal gradient in this area, so that's how hot it gets as you get deeper, were about 30 degrees every kilometre. But we found at the living lab it was actually about 60 degrees per kilometre. So what we want to know is that an isolated impact or is it a regional effect? So with some support from the Environment Agency and Town Rock, we went and profiled different boreholes around the area. And what we found was that in the high main system, which is that shallower system, at the living lab, our profiles were between 30 and 60 degrees, but the regional profiles in the same mine water block were between 20 and 30. And this is just shown on here. So this dashed line is the data we thought originally. We thought it was about 34. The profiles kind of below that are the ones we've got in the regions, and this is the one we got in living lab. So we've kind of got this higher geothermal gradient in this area. And again, in the deeper mine system, again, we see this higher gradient as well. So regionally, in the same mine water block, you're getting kind of between 40 and 50. And in an adjacent mine water block, you're a bit lower. So that's an interesting thing to explore further. We haven't looked at that further, but it's just some of the work that we're doing alongside it. So that's kind of living lab, and I like talking about living lab, but we've also recently done some really exciting projects. We've got 1 minute left, okay. So we've done a really exciting project called Project Impact. So what that is it was investigating mine potential for cooling and thermal storage. So this is, we know that thermal energy storage is going to be vital for heat decarbonisation. So what we did was we undertook a thermal storage test at UK GEOS in Glasgow. And really, it's the longest and the hottest heat injection test that we've done. And we did this through the support with the BGS, but also SEPA gave us permission to go above their licensed condition of 25 degrees so that we could really push the boundaries and see what happens when you put heat into the mine workings. And so that was really exciting. So there we are, that's us on site, I think switching on the site. So what we've got here is We abstract from the deeper system and we re-inject it into the shallower system to see what happens to that thermal plume when we put it in. And what we were looking at is what are the environmental impacts of that. So I've got some little bits of data here. So it just shows the temperature as you're increasing through time. So this is before test and this is after test. And what you can see is the heat's really, I would imagine, is going to flow along these pathways of the mine workings. So the heat is flowing where the mine workings are, and also, as you can see, a bit shallower here. You've got the heat there too. So this again, we're going to make all this data open access so that anyone can use it. We've just finished the test, so we've not got the data fully compiled yet. But yeah, it's really exciting because I think heat storage is going to be one of our next things in the future research. I'll skip past some other research outputs because I'm running out of time, but we've done some drilling success rates, myth-busting research, and also looking at different opportunity mapping reviews. And I think Milene's talking later about some of the work we've been doing with BGS on sustainable heat recovery. And we also do support external research, so we're always happy to talk to anyone to look at our data and help provide and help collaborate as much as possible. So, in summary, mine water heat is a proven technology in the UK. There's about 10 megawatts installed, and the Mining Remediation Authority are accelerating mine water heat through open access data. We're doing cutting experiments and providing the data open access, and also trying to help understand the risk around these systems. And also we're trying to help support and develop the next generation of geothermal scientists, and really developing the future research activities. So there we go. Thank you very much.